Thanks, Kevin, for the warm introduction, and thank you, Dan, and the team from Mazak for having me again this year for the Discover event. I really always look forward to coming in and speaking at this event. Automation has been and continues to be one of the key drivers in our industry, and I hope today to be able to share with you a little bit about what's new and what's next, and field some questions, talk a little bit about the market, and as the title mentions, driving results with automation. I think that's really at the core of what we want to do is we want to drive additional results, whether that be better quality, better throughput, trying to supplement the lack of the labor that's in the marketplace today, and so I want to focus on some of those results. At FANUC, we have a very simple mission. Our mission is transforming the world through automation. And I think that lends itself well to what we're talking about today, which is driving results with automation. I'll start to use our latest technology. ChatGPT helped me with this picture, and so I said, put a picture of a FANUC robot driving a Mazak car, and this is what came out. So it's getting really good at this, just to show you where the technology is headed. So I'm starting to use those latest technologies. But thinking about what the time is, I've been given a presentation like this. As Kevin mentioned, I've been at FANUC for a long time now, since 1999. And I've been preaching and talking about robots and automation for the last 26 years in a lot of different roles, all the way from the factory floor up until this current role. And I want to try to explain and show you why the time is now for automation. It's not that the time wasn't now previously, but really the way, when you look at the data and you look at what the market is, it really the time is now to think about and invest in automation for a lot of different reasons. And the very last slide I have kind of sums that all up. So let's talk about why. Another ChatGPT picture, by the way. These are all public pieces of information, but it's a way, where's that? Sorry about that. This is a good way for me to summarize kind of the why. And the first is looking at a couple key points of public data. This is what our industry and our companies look at when we see about automation. And the first is unemployment. And this really gets into whether or not there are available workers in the marketplace to be able to do the things in manufacturing that we need to do. And although unemployment in manufacturing has been ticking up a little bit, I might actually switch to this. Can you hear me now? Okay. So when you look at this data, if you look at my red pointer there, you can see it. Unemployment has ticked up. This is the last 25 years of unemployment. And what you can really see here, the point that I wanted to make is that really since COVID, which is that spike at the end, unemployment has been low, kind of historically low in manufacturing, that there aren't very many people that want to have it. The people that want to have a job already have a job, and that there aren't too many additional people looking for jobs because unemployment is so low. Recently, in the last year, it has ticked back up again about a point or so, but it was hovering under 2% or under 3%, I mean, right at that 2.5% for a very long time. And when you look at historically, so this is like since the beginning of time, 1950s, and when they started tracking the data, you can see that there's only a few points in time where the unemployment rate gets down into the level that it is. This is all employment. This isn't just manufacturing. This is all employment. But I want that to kind of be the basis point to say that right now in manufacturing, the unemployment rate's really low. We pay close attention to that because it lends itself well to whether or not you have the ability or the opportunity or not to actually use your machines in production, because there's not enough people to be able to do that. The next thing is job openings. So first was whether or not there's a lot of unemployment in the industry, which there's not. And the second is how many job openings there are. So this is out of all the industries in manufacturing lumped together, how many open job openings there are. And right now we're sitting at over 400,000 open positions. So we have under 4% unemployment. There's 400,000 positions open in the marketplace, which means that for those of you that have machines on your shop floor, it really leads to that you can't find the people to be able to do that. That's not even getting into whether or not the people that are available are skilled enough to be able to operate and run those machines and things like that either. So we have a big labor problem. That's kind of the basis of where I'm going to start from, is that there is a labor problem. We have talked about this for a long time, that this labor shortage was going to come when the baby boomers retired, which they have and they are, and a few major events like the Great Recession in 2009, like COVID, really wiped out a lot more people from our industry, and it's really pushing the need for automation because there's just not enough people to be able to do the amount of work that we need to do. So talking about, is there enough work to do out in the industry, we also look at capacity utilization. And this is just for manufacturing. This data gets broken down more detailed in other areas as well, not just all manufacturing, but this is just manufacturing. And you can see that we're sitting right now at about 77% utilized. So that means that the factories are pretty much running. That when you look at in history, 25 years of data, we kind of had the pre-Great Recession data here, and then after that, we've been sitting around that 77% range, and business was pretty good back then. So we're at a pretty good rate from capacity utilization. Industrial production is another piece of data that we look at, and this data got, if you read, I'm not sure where it's normalized. It's normalized in 2017 at 100. But you can see here for really the last 10 years or so, industrial productions had been at really kind of normal levels there. So industrial production is going well too. So there's not enough people, there's too many job openings. There's a great need to make stuff, and that really lends itself to why there's a push for automation. I'm just going to touch on this for a second. Someone presented this to me and I thought it was really impactful, so I added these slides that if you haven't, as the end users, for the end users here in the room, as well as for the Mazak salespeople and whatnot, if you haven't paid attention to or started to utilize what the new tax code offers you as a manufacturer, it's something you really got to dig in and pay attention to, because we can talk about tariffs for a little bit at the end. I can take those kinds of questions, but this does offset a lot of those, and this is a good one. If you're going to get this material, you can just do these. That number one, we still have a 21% corporate tax rate. That was important. The 100% bonus depreciation on all the stuff that you're going to buy from Mazak this week is really important, that you can depreciate that right away. You can buy a couple robots while you're at buying all the machine tools too. Section 179 expensing, the advanced manufacturing investment credit. This is important. Like I said, these I'm not gonna spend too much time on. This is an important one for builders like us and for Mazak, and then potentially for you in terms of being able to depreciate your R&D expenses. You used to have to kind of stretch that out over 5 years, and now you can do it all in the same year. Adding back in the EBITDA part of your interest deductibility changes. And then this is important as you grow. You have to meet a number of different qualifications for this, but if you're gonna start a new manufacturing building, so you're actually gonna build a greenfield site and you're gonna do production manufacturing in it, you can deduct all of the expenses to that in its first year, where you don't have to spread out that tax implication on you over a period of time, where you can take 100% tax depreciation on that in the first year, which is really important. So the big beautiful bill, or whatever they're calling it now, that there's a lot of really cool things in here that should promote additional manufacturing when it comes to depreciating the capital that you're going to invest in, depreciating the R&D that you might use to get that capital going, and then if you're going to actually build greenfield properties, you can even deduct that from your taxes as well in the first year. So there's a lot of really great things that are part of that bill that should be promoting manufacturing. It's kind of been dampened with tariffs a little bit, but I just want to make sure we highlight that in terms of why now is the time. That in the previous 4 or 5 years, all of these things were in limbo or didn't exist or were worse than they are today. But this is a very pro-manufacturing tax bill that got passed. I'm going to briefly talk about the overall robotics market to just kind of give you a sense of how many robots are sold in the industry. So this is, I'm sorry, the data, when I collect the data, it's based on FANUC's fiscal years. FANUC is we're a Japanese robotics company, and so our fiscal year starts on April 1st. So these fiscal years represent from April 1st up until March 31st of the prior year. And so that last piece of data, fiscal year 2024, is the data that ends at the end of March of 2025, is what we're looking at. And you can see here that overall, in the whole industry, we're selling about 30,000, 31,000 robots every year into the marketplace. And so I show you that to think that if anyone in the audience still thinks that robots are new or they're, it's emerging and things like that, we're very, very well established. This is a huge amount of product that gets pushed into the industry. You can see in 2021 and 2022, for various regions, we're the highest the market has ever been, ever. And I also want to show you how it divvies up between automotive and non-automotive, because a lot of people think that this entire market is just welding cars together and painting cars and putting EVs together, and that's not the case. That this market today is actually more non-automotive than it is automotive, which has been a trend that's been happening over the last couple of years. So this is the whole market. As I get into the automotive market, you can see, as I mentioned, there's 31,700 in this fiscal year, and it goes down to 15,900. So in this, it's just about 50-50 between automotive and non-automotive in the overall market. And now you can see that there's a big spike in the automotive. There's a big spike in 2022, and that was when a lot of the government funding for EVs was happening, and a lot of the automotive OEMs were really focused on trying to invest in their plants to try to build more EVs because the government was saying that was a good idea, and we saw this spike here. It's really negatively affected us in the last few years because those investments really haven't come to fruition in terms of the volume of the EVs that were actually produced, and you can see what that's done in the automotive business, where the market has become a little bit depressed over the last couple of years there. In the general industry market, so general industry is everything non-automotive. So this gets into a lot probably of your businesses in terms of aerospace, consumer products, pharmaceutical. As you get further down the tier market in automotive, some of that might show up here as well, but heavy agriculture is in here, food and beverage and things like that are all in this market. What you see in 2021, this is kind of a post-COVID, like that spike. Number one was a lot of run-up in the consumer products industry, where the warehousing and distribution markets were investing quite a bit. And also, if you remember the big lineup of container ships that were sitting out in the Pacific Ocean, where there was a big supply chain challenge, there was a lot of orders that got placed here because our lead times were really long. And so this was a bit of an artificial spike in 2021. And now the market's kind of stabilized here, where it's been 15, 16, 17,000 robots every year. And so I wanted to show this to say that even though that you might read about the economy, or you might feel things about the economy, the robot market's pretty stable. It's not where it was 3 years ago or 4 years ago, but it's been a very, very stable part of our business and a stable part of the market overall. We have data. This is fiscal year data, step by step of fiscal years. This breaks it out by quarter, where you can kind of see this. Really, the biggest thing I wanted to show you here is the differences in the markets, where this is the overall market, but you can see in the automotive OEM market, this is the robots that we sell directly to the car companies. This data is really choppy. That being in this data as a robot company is very challenging, because you get really high months and really low months. And the automotive industry has always been structured this way. When a big program happens, we sell a lot of robots, and then the next quarter you may not sell any robots. And so this is a very choppy market. But this part really highlights some of the issues that have been happening with electric vehicles. I mentioned that, I'm going back a slide, that in this 2022 and into 2021 time, you see some of those really big spikes. Those are all investments by the automotive OEMs to make electric vehicles. But unfortunately, the automotive tiers, the companies that do the automotive parts for the cars, they typically will follow this investment. So an automotive OEM invests in automation, they build a big plant, and then as soon as that plant's up and running and making a lot of cars, then the automotive tier companies have to come in and then they have to automate because they have to supply the parts for the cars. Unfortunately, with the EV business, the volume of the EVs never really achieved what people thought it was going to be, and so that the automotive tier companies never fully invested the way they could have because the volumes of the cars weren't there. And you can see that in this data where you can see what some of the automotive tier companies were doing up through 2022, and then as we got into 2023, that business really dropped off as the automotive components business was kind of waiting for the EVs to spark back up again. I tell you all that because when I say now's the time, it's because now the federal discount on EVs is gone. The $7,500 is gone as of this month. There's been a huge now reinvestment by the automotive OEMs in gas cars again. And we expect this part of the market, which I think some of you guys play in, to really start to pick up because we're seeing a lot of the powertrain companies and the automotive OEMs and their tier companies really start to focus back on gas cars, which is what our market, I think, is still wanting, trucks and SUVs and things like that. And so we think that this is on the verge of a pretty big pop that's going to come up in this market, which is going to maybe put the need for more automation, more machines in your businesses as you touch that automotive tier market, and because this is a little bit closer maybe to your business. In the GI market, we're already starting to see, of course, one quarter doesn't make, it's not a whole trend just for one quarter, but we are starting to see more and more investment where you can see those last two fiscal years from 2023 and 24 are pretty stable, but this first quarter for us, that would be April, May, and June of this year, were pretty good, and we think June, July, and August was also pretty good as well. So we're starting to see a pretty big uptick, and this is all the non-automotive business here in the market. So that's just a little bit about the automotive market overall. So it might be good for me to pause. I'm going to take questions at the end too, but before I move on to kind of some of the details in the machine tool market, is there any questions that you guys have about the overall market? We're going to make this a little interactive today. Okay. All right, so let's move on. Let's talk about the readiness of the overall market. I'm going to collect my thoughts here just so I remember what's next. Okay, so why now? I talked about a couple of things already. Number one, the skills gap and the labor shortage. That's been like a train that a freight train that we've been seeing running into a brick wall for a long time. The 3 Ds of manufacturing, we talk about this quite a bit: dirty, dull, and dangerous. Those areas of your operations where if you can't find people in the first place and then you have some operations that are dirty, dull, or dangerous, is really the perfect spot to start for automation. The other thing that's important to recognize, and I'm going to touch on this a little bit later, is that ever since I started giving this presentation, the workforce is also changing quite a bit. Where now the incoming people coming into the manufacturing workforce are much more adept to programming robots, fixing robots, understanding robots, that we've been putting robots into schools now for a long time. I've been CEO for the last almost 10 years. It was a big part of my predecessor's job at FANUC as well. And right now, we have over 5,000 robots that are in high schools, community colleges, and universities, all teaching the next generation of manufacturer these new and different kind of skills. And so I used to get up here and try and convince you that it's not so scary and that everyone can do it. But now there's a lot of confidence in the workforce because the kids that are coming into the workforce now are really, really well trained. Certainly the big thing to talk about is that there is this overriding desire from starting at the administration, our current administration, all the way through to make things in America. And so I think for a lot of your businesses, we can talk about that it's important that there's a top-down approach, that people want to make stuff here. But to be honest, it's not just America. I think in general, around the world, people want to make things where they're going to consume things. That we have all been trained, like Amazon, that if you order something, you're going to get it the next day. And that has really pushed companies to be able to locally manufacture, to be able to deliver a product very, very quickly, and something that might be very customized or something that might need to change very quickly. And so overall, there is a nearshoring, reshoring, onshoring, however you want to call it, especially in America, but I think all over the world that's happening. And that's good for us, that we want to make more stuff here anyway. And then the other thing is that we recognize very clearly that many of your businesses need a high level of flexibility, that a lot of your businesses are not that where you're going to make the same part for 2 million times in a row exactly the same, that you might get an order for 1,000 parts, you might get an order for 10 parts, you might get an order for 1 part, and I want to show you how automation can do that. And as you go outside, for those of you that were on the tour this morning, and when you go outside, you're going to see a lot of those examples here on the floor at Mazak today. Some of the reasons why automate, efficiency gains. This gets into some of the payback or the justification of automation. Why the justification? The first thing is cycle time reductions and increased throughput. Automation will work every millisecond of every day. Literally the millisecond that the door opens, the robot's putting the part into the machine. The millisecond that the machine stops, the robot's taking the part out of the machine. And so you end up, those little fractions of seconds all throughout the day, while you have automation doing this kind of work, really adds up. And we have great examples, Mazak has great examples of what companies did when they had non-automated and automated processes on the same machine, and how much throughput, additional throughput they could get pushed through the machine just by automating. Improved process consistency and part quality. This comes with, I think, the automated handling of it, where you don't get as many misloads. You can ensure that each part can be inspected. I think there's a system out on the floor today that integrates some gauging, where you can do 100% inspection of the parts very easily with automation. And now, automation is much more accessible to small and medium-sized shops. The picture I pulled here is from the Mazak website with some of the automated cells that they have, the Easy Loader 20 and the Easy Loader 30. These types of cells, these small, pre-made, very cost-effective cells, are really pushing and driving a lot of automation into the small and medium-sized job shops and manufacturers today because of how simple they are. They're portable, so they can plug right into a wall. This is not something where you need a power drop for. Some of them don't even need an airline drop to it, where you can push it, wheel it, cart it over. Some of them actually are on AMRs. That's an automated mobile robot where they can actually drive themselves to the location. And there's a lot of tech involved in that, where they really self-program themselves too, using some pretty cool technology. So all of this is becoming much, much more accessible today. A couple other things that you have to consider, and these are some of the gotchas that sometimes people don't think about when they start to automate, that people, that human workers might do in their factory, that then the robot has a hard time with. So number one, just looking at the overall operation, is it repetitive and consistent? If you're going to start automation, if you haven't automated yet and you're going to start automation today, you really want to look for the low-hanging fruit to get your feet wet and get into it. One of the big things is getting into coolant and chips. That you don't quite realize how often a person might use the coolant nozzle to spray down something or take some stringers out of the cell, and that becomes very apparent. The picture here at the bottom, actually I think I duplicated it on the next page as well, that that was a real job that we did when we started to automate it, and we realized that without good chip control, that's what happens on an automated cell, because there's nobody around to fix it when that starts to build up like that. And so these are some of the things, and this is where I have to give Mazak and their team a lot of credit, that the machines that they make, the application engineers on staff, understand all of this stuff as you start to do it. Same thing with the distributors that are in the room, that there's a lot of really great distributors that understand this part of the automation business. This is where I was talking about the stringer management, and then getting into automation friendly. This is a part where this was much more difficult. As I got up here and talked maybe 10 years ago, the automation friendliness of the machine itself used to be a little bit of work, that you might need to call in an application engineer to write some custom ladder to get the automation to work, or you were trying to hard code sensors onto the machine to understand when the door was open, when the door was closed, when the chuck was open. That kind of each project was its own little science project to automate. And that's really not the case anymore, that these machines now come with automation packages built into it. The communication protocols are built in. You know, it's one plug, it's just one Ethernet plug or one communication plug between the two to get them talking. I'll show you on another picture that now on the Mazak control, there are built-in screens that the automation actually shows up right on the Mazak CNC screen that mirrors then what's on the robot screen. And so all of this automation friendliness has really evolved quite a bit over the years. And then I have another slide on this later, but controlling the part presentation, there's so many different ways. This is the cell on the bottom here is another automation company called RoboJob, and they have a part presentation method. I can't remember, Paul, do you have one on your floor today or no? Not today. Okay, so this is another one. They partnered with Mazak in the past, but they have another kind of nesting solution there where you can organize the parts and things like that too. So getting started. Hopefully I said some good things, and you might think, oh yeah, maybe that sounds good, maybe I'll try to automate. This is really where you want to start. When you look at your production facility, right away you got to look for the bottlenecks. You look at your overall production facility, and you can pretty quickly understand where the bottleneck in the operation is, and that's a really great place to start. So maybe it's that there's a lot of rework that needs to happen on one of the operations, or maybe that because of the setup that this particular operation runs a little bit slower, that the loading and unloading, the manual loading and unloading is hard. Or maybe you get into a part where one of the jobs you have is so undesirable that it is the worst job in the factory, that half the time the employees don't show up for that part of the plant, and you have an absentee issue. A number of years ago, when we would talk about justifying automation, we'd always look at, how much scrap did you have that we can fix with automation? How much labor replacement can we do to try to save money? And recently, we talked a lot about absenteeism as one of the main justifiers of automation, where if you looked at your days of production and you had to shut down various areas of your production throughout the year because people didn't show up for work, that really changes the automation justification when the whole plant shut down just because you can't run a part of your factory. And so that's where you get into either looking for bottlenecks, trying to find the sources of the downtime. Those ROI bits, number one, the automation is becoming much, much more affordable today than it ever has. You can add really advanced vision systems, and I'll say the word AI. I don't normally talk too much directly about AI in terms of this, but I'll talk about it a little bit as I get through this and where that is, but it's all becoming really, really affordable. And then the biggest thing is just start simple. If you've never done it before, try something easy. I'm always amazed at when I go through a plant and I see how some people automate, and I've seen some areas where there's a spot where the robot's literally just reorienting a part step by step, and I asked the customer, what are you doing there? And they said, we had a really hard time finding a solution, a hard automated solution to reorient this thing, and so the robot just sits there all day long and just like moves apart a little bit all day, but it helps their production. And the same thing with manually tending and easy, like a lathe or something. It's a really, really simple thing to do. And then I'll show you later that cobots, that I have a couple more slides, the difference between a traditional robot and a collaborative robot, that's a name for a cobot, is a really easy thing to put on your floor because you don't have to worry as much about fencing it off and safety and things like that. So here, touching on cobots. So first and foremost, pre-engineered solutions. A lot of pre-engineered solutions come with cobots. They don't have to, but a lot do because you want them to be small and flexible. So we have some of the Mazak cells, some of the integrators that work with Mazak, some of their cells. They come in different various shapes and forms, but a pre-engineered cell, what that really means is that whether it's Mazak or one of the integrators or distributors has kind of thought about some of the things that you might need in that automation cell. So you're not just buying a robot, you're buying something that has more than just the robot. So here you have the robot is already on a stand, and that stand has wheels so you can move it around. It has some of the controls package already built into it, where this one has an integrated cart, this one is integrated to a pallet, that you can see that in various ways you can pre-engineer something depending on what you need. If you were trying to automate a lathe or a mill or something else, some of those fixtures might be a little different. And always there's software built into that where they will pre-program the robot to do what you need based on the type of infeed that it has. Like in this case, this robot will have either a pre-made vision system on there to take a picture of it and find these parts with a camera, or that, like on this one, it could be fixtured to the robot where it doesn't need a camera necessarily because it's always going to the same spot to pick up the parts, the incoming and outgoing parts. So each one has its own little flavor. They're very, very easy to use, number one, because first and foremost, a cobot, the way you program a cobot is a lot easier than a traditional robot. It's low cost because there's a lot less safety hardware that needs to be put on when you have a collaborative robot. No fencing, easy to redeploy. This is an important one where if you're going to invest in automation, say you're going to invest $100,000 or so into an automation project, you want to make sure that if you have a job that's on this one machine and maybe that job expires or you don't know what's coming next, you might want to move that automation to something else. And previously, it could be very difficult. You're unbolting stuff from the floor, you're moving fencing around, and, things don't match up. You have to call someone to come in and reprogram everything. And now with these easy-to-use pre-engineered cells, you're literally just wheeling it to the next machine and teaching the new pick point and place point inside the machine, and you're up and running again. And so they're very, very, really very easy to deploy. And as I mentioned before, it's an easy entry into robots in general. They're very lightweight. We just came out with a version of that robot that it's small. It can only pick up 3 kilograms. It's meant actually for the shipbuilding industry, where there's a huge need for automation in the shipbuilding industry right now because there's not enough people that can weld ships together, and we want to make more ships. And we made this robot where you're going to put a magnet on the bottom of it, and literally someone can pick it up and stick it to a ship, and it's going to weld in its little area, and then someone's going to move it and stick it to the next part of the ship, and it's going to weld in that area. And so now we're really coming up with very just extremely portable robots, where these robots aren't heavy. You can wheel them around really easily. There's easy gripper connections where you can change the grippers out depending on what part you need to do. A collaborative robot in general, for those of you that don't know the difference between a traditional robot and a collaborative robot has a sensor in each of its joints to measure the force that's applied to it when it's moving around. And so the collaborative robot then, that's the way where if it touches you, if the robot bumps into you, it'll stop because it feels a difference in those sensors. Those sensors also can be used to do what's called manual guided teaching, where you can put the robot in a teach mode and you can actually grab the robot with your hand and move it around because those sensors are feeling the force that you're putting on the robot, and you can freely just jog it around using hand guided. And that's really a good way to teach somebody that may not know how to detailed program a robot, and teach them a really easy way to program the robot through this manual guided teaching. That also makes it easy to install. There's a lot of different ways to mount it and things like that. So just to be clear, you can do it. I just throw that out there. And here's a couple different reasons. So first and foremost, and this is kind of a summary now, that they're really not that complicated, and connecting them is really easy. This doesn't get into rocket science. Number two, as I mentioned before, these collaborative and movable and fenceless cells make it easy. So first and foremost, that connection is very easy. Second, that having these fenceless cells makes them easy to automate and easy to move if you need to. I talked about this before, but there's a lot of different in-feed types. So this particular cell, you can see, just uses some fixtures. So this would be very simple where, depending on the part size, you can change the top plates of these, so you can have big ones and little ones and all sorts of different sizes. And the robot's really good at math. So if the robot knew like where this corner was, and you can say that, and it knew where this corner was and this corner was, because that was pre-programmed into it from the distributor from Mazak, and then you told the robot that I have a 6x5 pattern, it would know where the center of each of these things was. So if you said, here's one corner, here's the other corner, and I have a 6x5 pattern, and the part's this diameter, it knows without any sort of programming where to go to this whole thing. Because it'll know where the center of this one is and this one is, all just by math. And that way, if you get a different plate and you say, well, now I have a 4-inch diameter part, and now I have a 3x5 pattern, the robot already knows where it is too. So just by putting the part data into the robot, it can figure out its pick points really, really easily. And then because the chuck's always in the same spot, especially on a lathe, your place point's always the same no matter what size the part is, because you're just going into the middle, and it makes all the programming very easy. That'd be like on a fixture design. There's conveyor designs, there's pallet designs. You can, like the cell down at the end is structured like a semicircle, where this has parts coming in on a conveyor one by one. So there's a lot of different ways to solve your problems through that. Or you can go completely unstructured, and there's some examples of this out here, where you can use a vision system to go try to find stuff that's completely unstructured. So these are pallets that are just kind of loosely put in place, or over there, same way, they're just very roughly put in place, and then you can use either a 2D or a 3D vision system to do that. And this is where I'll maybe touch on maybe what's next, and some of the AI that's out there today. There's a lot of development going on in giving a robot a sense of sight and then allowing it to move around based on that sense of sight. In these examples, you are going to train this part what it looks like to the camera. So the camera's going to see that, and then when the robot takes a picture of it, it's going to know where to go because you've taught it that in the past. There's a lot of development going on around not needing to be able to teach the robot what it's actually looking for anymore, that an AI engine is going to figure that out on its own based on what it may have seen before or some general guidelines that you gave it in the first place. And so there's some new developments going on where, in this case, this robot would basically teach itself what to do, where it would come over and look at this, and without anything, it would recognize that that's a part and that the center of that part is kind of like right here, and then be able to go pick it up from there. And the AI engine kind of takes over for the robot and programs it directly. And that's kind of next gen things, but it's happening in the marketplace today, where if you went online and you looked up Amazon robotics, is a good place to go. You could go online, you just Google Amazon robotics, and you can see a bunch of examples of what they do with their robots. We're not allowed to officially talk about any relationship there, but if you look at the YouTube videos, it can be very clear what they're doing. But those types of systems, all those robots are completely driven by AI. No one programs that. It's driven by an AI engine that's not embedded into the robot, and that AI engine is telling the robot dynamically what to do in real time And that is kind of coming to the world of machine tool automation right now, which is an important part. But in terms of this kind of stuff, this is all simply done by pick and place teaching, which is really, really easy. Another thing I touched on before is people. This is something I want to make sure I have a map for you. So I talked about this 2 years ago when I was here, and I actually didn't even change this slide except for update the numbers, because this is still so important that I want to challenge everybody here in kind of in terms of what your duty is as a manufacturer and as a member of your local communities, that everyone needs to find more people that get excited about manufacturing. And one way to do that is to partner with education. And so all of us probably don't have enough free time, and we all have hobbies and other things that we want to do, but kind of talking to other people about why manufacturing is good and why it's a good career and why it's been beneficial for us and our families is important. And in order to do that, we have to teach young people why what we do is cool and important and that kind of stuff too. And that all happens at the education system. And so I spend a lot of time, and I would encourage all of you to spend a lot of time, that if you are having a hard time finding people to do things within your company, try to partner with education. And what I mean by that is go to your local high school, who probably has a career tech division. Find your local community college, which would be delighted, because you're all leaders in your communities, and talk to them and say, I am doing advanced manufacturing, and I want to implement automation in my factory. Could we partner together to try to find a link between those two? And once you do that and start to engage in those areas, you can start to build up a relationship with schools. And every dot on this map is a school that has a FANUC robot in it, teaching a kid how to do next generation manufacturing work. It looks like that picture over there was just a small robot. We make collaborative ones, we make traditional robots. We donate all of the software that's needed, the virtualization software that comes with that. And this is kind of like the gift that keeps on giving, where we started doing this, and now everywhere I go, I meet people that say, oh, I programmed a robot in high school, or yeah, I had one of your robots that I touched here, and it builds a confidence and a comfort level where this is just going to start being part of everyday life. And so, but it takes that first step, and it's convincing a kid that it's important. It's convincing that kid's parent that getting into manufacturing is good, or that going to community college is good, or that going right into the workforce right out of high school is good, if that's a career path they want to take. And that momentum is starting quite a bit now, and you can see in this map here, I think this room is a lot of people from the Midwest, and so you can kind of look at that, and we have details on each one of those dots. So if your factories buy one of those dots, we can put you in contact with some of those schools. It can be a really good feeder of new talent into your organizations. And so although we sell robots and robots handle a lot of these dull, dirty, and dangerous tasks, we still need many, many more people. Like I said, there's still 400,000 open jobs in the industry today that aren't being filled, and it's really hurting how much we can make and what we can do. Okay? So here's my final checkbox. So why is now the time? Why is now the right time to start thinking about and doing automation? Number one, unemployment's low. Everybody that has a job, everybody that wants a job has a job right now. There's 400,000 open jobs anyway. We can't even fill those positions. Business is good. There's high capacity utilization. President Trump, all the way down through the administration, wants to bring manufacturing back to the Americas. We have strong government support for automation now more than ever. And as I mentioned before, we're starting to educate the next generation of skilled workforce. And then finally, as I talked about in a bunch of those pictures, that these robot systems are becoming easier and easier and easier to use. So what do I do? Where am I going to get started? So number one, talk to Mazak. Paul Robinson here leads up the group. That there are a number of detailed resources within Mazak. Talk to your distributor. I know a lot of the distributors in the room also are very, very good robot integrators as well. So they have brought robot integration inside the distributorship so they can provide that solution to you. Go find some low-hanging fruit, go pick an application, just find something in your plant and just give it a chance. It's a very low investment, the barrier to entry is very low these days. And then find an integrator, whether that's a Mazak, whether that's one of your distributors, whether that's another integrator, whether that's FANUC, but just find somebody, and then in the end, if you finally need to talk to us, we're always here to talk to you. I've got a couple of my sales folks here through this week as well. So that's kind of your roadmap in terms of getting into automation. It really is the time. I mean, there's a need. I think that seeing how many people are in this room is probably indicative that you're interested in thinking about it. And if you haven't done it yet, or if you did it a long time ago and it didn't work exactly the way you thought it was going to work, it's time to give it another chance, because it really is pretty simple to do and a low barrier, and now's the time to do it. Because if you don't do it now, you might fall behind some of your competitors that are going to do it. And that's all I had. So my final picture, and let's go. It's time to drive towards automation. So, thanks.